Yeah. Okay. So we actually yesterday, those who have seen the video, we were discussing about cloud-based services. Okay. So IoT cloud-based services. In that, yesterday we learned about Zively, and today we will be learning about Nimbits. Okay. So now, what is Nimbits? Now, it is a platform as a service. Okay, that is PaaS. So we know that four kinds are there: IaaS, SaaS. Um, if see now, actually, I am in the PPT mode. So if anybody has to text, please unmute yourself and just tell. I think class seers can tell if it is not audible or not visible or anything, because now I can't see the chat. Okay, it is the duty of the CRs to unmute themselves and they have to tell me the problem. So we were discussing about four kinds, okay, of the service, that is platform as a service, data as a service, infrastructure as a service. Okay, so this one now here Nimbits comes as the platform as a service. So it is an open source. Okay, you can use it to develop software and hardware solutions that continuously connect to the cloud, okay, and each other. Now Nimbits server is the core. Okay, it provides REST web services for logging and retrieving data. Okay, uh, and geo-stamped data. That is like temperature. Okay, such data continuously. If you want to monitor or something like that, then we can use this platform. Okay. Now, for the incoming data, Nimbits servers records the incoming data, and each new value triggers an event like an alert. A calculation will be done. Okay, then a message, okay, is sent. An alert or a message is sent via a path. Okay. Now, newly calculated values can be automatically recorded to another channel with more and more computations. Now, actually, if you see in the next, I'll show you the diagram. That time you'll come to know this Nimbits server will be present. Okay, that is a feature of the Nimbits that is present at the remote nodes also. Okay, from there it connects to the cloud. Now, features are it supports multiple programming languages like Arduino, new Arduino library, JavaScript, HTML, etc. It acts as a backend platform. It can relay data between software systems, okay, hardware devices using the cloud. Okay, it uses an open source Java library called nimbit.io for Java development. It provides rule engine to connect sensors, okay, persons, that is devices and softwares to the cloud. Next, see, if you see the pictorial representation, see here, as I said, at the device end, okay, that is IoT or M2M end, we have Nimbit server. Okay, we have Nimbit server and XMPP server. Okay, this is the protocol. Now the data feed channels, okay, that is a feed. That feeds are nothing but the like a collection of data of a particular sensor. Okay, like that it is. So those are connected to the internet. Now this Nimbits connects to many devices. Okay, many remote devices. So what are the functions of what and all it does? Okay, it has data points. Okay, it has child data points. Okay, then it has calculation objects, because this is a small version of a server. It can do, and it is connected. Okay, in some of the platform you see that this server is located at the cloud, and from there the controlling is done here to the remote area. But here actually it is at the remote area. So calculation objects are present here. Okay, then summary points we can have. Summary points are the result of the computed data. Then alerts can be generated. Okay, XMPP alerts and messages. Okay, you can have folders, subfolders. Okay, then security tokens can be generated, and it can be sent or received as per the requirement. Now this is at the cloud end. Okay, so here also Nimbit clients for data collection in real time, it accepts. Okay, then graphic graphical plots of collected data and data entry. Okay, so here databases are there. So whatever options are done, like operations are done here, same thing can be done here also if it is required. But this is the feature of the Nimbit. Okay, that is, these computations can be done at the remote end. Okay, Nimbit installs an instance, that is path, of a server at every connected device. Okay, Nimbit server L is such an instance of the Nimbit server S at the cloud. Each Nimbit server of the device generate a calculation object for device nodes. If in case if it is required, every time calculation object is not required, but in case depending on what type of application, okay, it can be generated. Each node also hosts XMPP server, an instance of the XMPP server at the cloud. Okay, that is the connection. XMPP server at each device generates data feed channels for XMPP messages to send XMPP server at cloud. Next, what are folders and subfolders? Okay, what are data points? It is a collected value of a sensor in a group of sensors. Data points. Data points organize the data in a number of ways. Okay, see example, points can have child points, sub points. Okay, this we will see while doing the example. Okay, so like uh, in a like what is that, a street light example, if you see data point, then light on or off is a child point. Okay, light level above or below the threshold is also a child point. Okay, in that again, if you want any further information, that again becomes the like leaf. So it is like a tree structure, one after the other, like for what you call subfolder inside the folder. Like that, you can go on generating the data for a different purposes. Okay, so folders and subfolders. Okay, points can be in the folders. The folders can go as deep as like in a tree. Okay, so tree means a folder having several subfolders, subfolders having again subfolders. Okay, till the leaf subfolder. So there is no count like how many subfolders a folder should have. Now, in case your main data includes many subdatas, then you will be having many subfolders to give in. Okay, if it does not, now suppose your main data itself is time, then again in that only one subfolder I can have is, okay, minutes, okay, one more minutes and seconds. Whereas if you have data as date, okay, then you are having date along with that month, along with that day, along with that year, like that, depending on which type of data I have. Okay, we are having subfolders. Provided subfolder is of any importance that plays any role in your computation. Okay. Next, subscription of data feed. A subscription data feed is a special point for each user that logs system messages, events, alerts from other points which are subscribed by the service. So actually, now this is you are sending a request and you are requesting for the alerts, messages, or any such things. Now, data channels. A user can create a data feed channel which shows the system events and messages. Okay, data alerts which are subscribed to show up in the feed. So a channel is created when when it is created when we have to send the data. Okay, collecting the data is different. Okay, storing the data at the remote end is different. Okay, in those cases data channels doesn't come into picture. In case you want to club that to cloud. Okay, when do you want to club that to cloud? When and all such situation comes, in case you want to store it for the further reference. One option, one possibility. And the second possibility is because this can handle nimbits can handle many users at a time. Another user wants to take your data for some computation. Okay, that time you are sending your collected data to that user through the cloud. Through the cloud. In that case, you need to request for a feed channel. I hope that is clear. Okay. Next, the features are an application can create a connection to another Nimbus application server. This is what I have already said. Okay. Now, H2 is a Java SQL database. The APIs are in pure Java. Now, I mean, that is a feature of this Nimbits. It is an encrypted database. Okay, it's very fast and it's open source. Now, what is jabbing? Okay, pushing alerts, notifications quickly or like alerting repeatedly. That is also called as jabbing. Okay, you are alerting repeatedly. Maybe like something you have scheduled or data has to be collected at each interval. Okay, your rainfall has to be taken for how many 24 hours. So after 24 hours, okay, you are getting the data, but along with that you are getting an alert saying that your data is updated, your database is updated. That is an alert. Okay, so repeatedly sending that. Next, each alert or message is denoted by JID, consisting of, okay, JID consists of node ID, domain ID, and resource ID. Okay, these are the features. Okay, if we consider an example, okay, see the question will be consider internet of automatic chocolate vending machine. Okay, assume that each ACVM device nodes generate the following data points. Okay, child points, and further uh, child up to the leaf, and also generate the summary points. Okay, so again in that only suggest the data point and child points for the system events and messages. Okay, subscriptions for the alerts to XMPP server and subscriptions to Nimbit server at the cloud. This is Nimbit server at the cloud. Okay. Okay, now if you see uh, data, what and all data is generated on each vending machine, chocolate vending machine. Okay, first generated is ID, ACVM ID for machine ID. I hope you agree with that. Okay, then time, date. Okay, time and date, at which time, at what time, when it was updated. Okay, it has sent the data. Then active status. Active status can be 1 or 0, on or off. Okay, so here we may not get, okay, further this thing, but if we get also, like it will be like uh, uh, if at all this thing is there, what is that, maintenance is there, when the maintenance. Okay, all those things we can include, but basically it is on or off. Okay, then other datas, okay, which you get it from ACVMR. Okay, that is chocolate flavor 1, okay, that is sold. Flavor 2 sold, flavor 3 is sold. That is how many chocolates are sold out. Okay, if you take five nodes, five vending machines, one, two, three, four, five nodes. Okay, then four will be data of first one, five will be data of second one, six, seven, and eight. Okay, so this is the data. These many are the data generated. Could be okay. You can add some more, but these are generally the data generated by the chocolate vending machine. Now, what are the data points? Okay, they are one is okay, data points for this first one. Okay, that is ID generation are that is ID, then time data, then chocolate unsold, then chocolate request pending. Okay, see, these are the data points. At the end of this, these four are the generated one. Chocolate unsold, that is left out. Chocolate request pending. Okay, request has come, but it is not been attended. Okay, ID has to be sent, then time date has to be sent, at what time it is updating. Okay, next for that first one only, that is which was the first one? ID, ACVM ID it was. The child points are, okay, first one is region, because we have five such nodes, five vending machines. So this is about which region. Okay, second one is address, it can be. Okay, then installation date it can be, then maintenance schedule it can be. Okay, service address. Okay, then active status. ACVM node domain address. Okay, domain address, which domain it is working in. So these many can be the sub data which can be generated, okay, under the first folder, under the first folder. Okay, when you design, you tend to get, because see, it has to be connected to the server which is at the cloud very like accurately. For that, what are the data which has to be cross checked and connected? So these can be some of the things which we can name them. Okay, for the second one, which was the second main data which was generated? Time date. Okay, so in that sub category, that is the child points, can be hour of and date, it in which hour, day on date, okay, which day it was, week on the date, month on that date, year on that date. Okay, so these many can be the sub uh, categories you can make. Okay, so that it is linked properly. Now child point of 3 could be, what was the third data which it generated? Yeah, it was active status, right? So active status can be, okay, 3.1 is chocolate flavor 1 unsold. Okay, flavor 2 unsold, flavor 3 unsold, provided you keep all this on. If it is off, then you don't get any data how many like it is unsold, because it is not in action, it hasn't done any uh, like selling or vending. Next, fourth one could be chocolate flavor 1 request pending. How many requests are pending? Okay, because that was the fourth one itself was the uh, chocolate, like how many requests were there. So after particular date and time, how much is pending, that can be given. Yeah, so like this we can have the what is that, data points as well as the child points. Now, coming to another example, that is switching on traffic light. Okay, so in that, initially in the north south pathway. Okay, so it means that in east west it should be switched off. In the north south pathway, the traffic light should be on. Okay, so the problem is there are three LEDs, okay, traffic light, red, green, and yellow, that needs to be controlled on each of the four clockwise pathways: north, east, south, and west. Okay, LEDs at 12 ports. So in each you have three connected to four pathways, traffic lights. So three LEDs per each direction. Okay, the 12 GPIO pins and connects 12 LEDs: R0, G0, Y0 to R3, G3, Y3. Okay. Now, coming to the solution, how actually it can be achieved. Each pathway has red, yellow, and green lights represented by LED R, Y, and G for each of the four pathways. Okay, 12 variables we have, that is LED R0, Y0, G0. Okay, R1, Y1, G1, R2, Y2, G2, and R3, Y3, G3. Okay, so computer is connected to the board using the serial pins. Next, the port LEDs at 12 ports be on off programmed. Some should be on, some should be off. Okay, north and south pathways traffic is switched on, and east and west should be switched off. Okay, so now declaring the data types, okay, constants, variables, and functions. Then it has to be like coding for setup and the loop. Now declaring, see, port numbers assigned 2 to 12. Okay, so 2 to 12 will be your 11 this thing port, and one more is port number 14, IO ports. Okay, so you connect LED R0 to 2, so like that you go on, and last one LED G3 to 14. Pin number 13 connects the board LED. Okay, so that is for internal indicating a successful running. Okay, so it is the internal LED. Which one? Port number 13. Okay, so the port number 13 is used to indicate successful running of the developed codes, okay, during the testing phases. Okay, next, declare the integers R0, then LED R0 says again, okay, void north south should be green. Okay, because there actually we should allow the traffic to go. So north south green should be on. So how digital, right? LED R0 is red, that goes low, Y0 goes low, G0 goes high. Okay, if you see digital, right, LED R1, okay, and Y1, G1, that goes low because it is in the east side. Next, R2, Y2, G2, okay, is in the south side. So it should be in that R2 should be low, Y2 should be low, and G2 should be high. Okay, so this is for the north south. For east west, okay, so the traffic should be blocked. So how do we do? Red should be high, yellow should be low, and green should be low. Okay, this is for the east. For the west side also, red should be high, okay, yellow should be low, and green should be low. Okay. Now, if you go for setup, say pin mode, and like this only, you continuously give the pin mode till G3, then pin mode for the port number 13, that is internal LED output. Okay, then digital write, then you go for a baud rate, that is the speed. Okay, baud rate gives you the speed. So it is 9600 per second, bars per second. Next, serial dot println control traffic lights. Okay, so it runs the following functions to make north south pathways light green on and east west red on. Okay, so this is what the program we had written. Okay, it was asked to write like that. So north south it was green, and east west it was red. Next, moving on to next example, write a program to switch. Okay, okay, fine. This actually what I will do is I will actually here LED is on for 30 seconds. Here these parameters you need to add. Okay, 30 seconds. 10 seconds will be the time between switch on of north south and switch on of east west pathway. That means what? In that 10 second, what should glow? Yellow should glow. Okay, initially we have done already. Two path should be green, two path should be red. Then intermediate 10 seconds should be yellow. Then it is interchanged. Okay, so the first two paths should be red, the next two paths should be green, like that. Okay, then it will remain for 6 seconds. After that the cycle repeats. It should remain there for 6 seconds, like that. Then the cycle will change. So this is the program for that. Now I since I will run this. Okay, I will show this, and I will give it as an assignment. Just go through that. Okay, just go through it. And I have asked you to maintain a book, right? In that book, write the program. Okay, when you write the program, you will understand actually what is it. Is easy. Like however we have just now we saw similar kind it is, but only thing is we have added the delay. Okay, in between, see here, the delay and the speed has been added. So check here, delay of 10 seconds. Okay, delay of 30 seconds. Okay, that time it was green and red. In between yellow comes, then again interchange green and red again, in between yellow comes. So this is the way. Okay, and it has to repeat for 6 seconds. After 6 seconds, then the serial port output you will get it. So this I expect you all to just write and analyze. Why am I asking you to write is because if you read, you may not be able to reproduce the same thing in the test or the exam. Okay, so it has to be, you have to follow the font. So if you write once, you will be familiar to it. Then comes, okay, next example. Sensor ADC output reading using serial input SPI. Okay, a temperature sensor used for measuring between 0 degree and 100 degree Celsius. So when it is ADC, so analog to digital, now this is analog. So digital should be like 100 degree should be all ones. 0 degree should be all zeros. Rest of the degrees should fall in between that. Okay, I hope that is very clear. Okay, the sensor sends analog input to an input of the ADC. Okay, input of the ADC. Input of the ADC is analog. Okay, then set interfacing a circuit such that ADC output for sensor at 100 degrees all ones. This is what I said. Okay, so it is if it is 1024 bits, Then actually we assign it from 0 to 1023. Okay. ADC output converts to serial by a parallel input to serial output. Okay. Parallel input PISO converter. The serial output connects to serial SPI input pin at Arduino Uno board. Okay. Now reading from sensors and devices using ADC. How will you read data from SPI input every hour into, check here, it is every hour, okay, into Arduino board from sensors. Sensors analog output is given to 10-bit ADC, and ADC's parallel output is converted to serial by parallel in serial out. Then it is connected to SPI input of Uno board. Okay, now again I request you all to, I will run this so you will get to know. I want you all to go through this. This is very easy. Okay, first include, then here one thing, okay, this has to be given, you cannot get that calibration coefficient. Okay, that should be given, so that here a constant is given 0.097752. Then you declare the float points. Where are we? Yeah. Okay, here also internal LED is 13. It shows whether your code is running successfully or no. Okay. Now degree Celsius is taken as the input. Baud rate is taken as 9600 per second. Okay. So internal LED and output, internal LED and digital output, it is high. Okay. How is the output? It is just showing if it is one star there, then LED is high, otherwise it is low. Okay. Now here, see, this actually can be changed. If you take 5 volts, then it will be divided by 5. If you take 3.3 volts, it depends. Okay, how do you take? Then you give it 3.3 volts. This conversion, you know that, correct? Okay. See here, internal LED high. Then okay, a loop is taken. Delay of how much was the delay? 6 seconds. Yeah, 6 seconds. Then it is okay. It is again taken here, whether it is high or low. Then again delay is introduced. So like this, it continues. So not this one till here. So this was another example. So we have studied about two examples. First one was actually how data points in that child points. Okay, for example, folders, subfolders, again subfolders, till you reach the leaf folder. Okay, was given in terms of an example. Then two examples we have learned. Okay, how actually it can, the data can be given in the nimbits. So this was about the nimbits, and yesterday we have studied about Xively. So this finishes our second module. Okay, I repeat, this finishes our second module. Okay, now if you want me to be in the PPT mode, I'll be in the PPT mode. Does anyone have any doubt? Does anybody has any doubt? Anybody? Okay. Now I'll only ask then. Sweden Lobo. Sweden, unmute yourself.
Yes, ma'am.
Okay. Sweden, are you able to get what I'm saying?
Yes, ma'am.
Okay. If you have, used your Arduino, see, I will tell you this topic, simply sitting at home and reading, I don't know, it may be a bit difficult, but actually if you google a bit, then you will get to know actually. See, some of you who has already worked in Arduino and all, you know what I'm telling. Okay, that will be very easy for you to link. When you are in fourth sem or fifth sem, sixth sem, you have worked on it. Now actually when I say in a theory, okay, it is related like this, it can access the node, what you call, it will establish the link, feed, all those you will get to know actually what I'm speaking. That is easier. But those who haven't worked till now, for you all know, it is really difficult actually about what I am talking. Okay, so which platform she is talking about, which software she is talking about. When I was talking about IoT, M2M and all, yes, I could tell you. Okay, it is at the remote place. Okay, and it is connected like this. And while connecting, these are the methods followed, and those methods we call it as protocols. Yeah, all those things. Okay, I could explain it to you. Now, when this comes, this is no platform on which it is working. We are working. Okay, platform on which we are working, because we have so many constraints. First of all, first and foremost is, okay, ours is IoT design. Okay, machine to machine or IoT design. So in this IoT design, it is not like at one place only we have. We have to consider that our nodes are at very remote places. Okay, and there the major problem is our power constraint. So I should look into a situation or environment where actually power consumption is less. Okay, so if you while power consumption is less and the data what I get is very feeble. Okay, because data are in analog form. Okay, it is completely corrupted by the noise and all. So whether am I able to send it like that, in the same way, or should I compute then and there itself? If I'm computing, what type of computation I should do? Okay, and which platform I must use? Then and there only if I have to compute. Okay, then see, sometimes it can be like uh, uh, let me tell you, some like fire in some furnace, some this thing you have kept, some sensor you have kept. That time one option could be, since that fire sensor is continuously giving you the signal, and here at the controls room, you are analyzing. Okay, how whether it is reaching the dangerous level, okay, or is it in the permissible level, that you are calculating. But sometimes if it is so urgent that immediately action has to be taken, then there is no time for those signals to come to the control room, and then there it gets processed. So then and there itself it has to get processed wherever the sensor is there. So in that case, which platform is used? So that about that we are studying now. Okay, I hope practically I make you a little bit aware of actually where we are, about what are we talking. Okay, so which platforms? There are n number of platforms. There are n number of in this syllabus. No, what is that subject? I request you to first go through simply. Okay, just type IoT protocols, something like that. You type, and whatever you get, you just browse. You don't spend too much of time. Okay, just 5 to 10 minutes you browse, then you come back and read the textbook or go through the PPTs or whatever it is. Then it will be like you will get an idea of what to read and what to leave. Okay, otherwise everything will be like Greek and Latin for you. Okay, whether you have to remember all those names, whether you have to remember all those bits, those many number of bits, all those that you won't know. But if you come to know actually about what I am studying, then it is easy for you to uh, get it. Okay, so uh, actually I have meeting today, so I'll wind up at around 10:05. Anybody has, okay, Anil Nair?
Ma'am, I had a question, ma'am.
Yeah, Sagar, yeah, Anil, I'll talk to you
Yeah,
later. Yeah, Sagar, tell me.
uh, ma'am, Yeah, I had one question on the hardware and software connection using IoT. For
Yeah.
example, if I have a robot and many sensors are connected to it, and I am using I'm not using any operating system on the robot. I'm
Okay.
virtually using some other operating system which is accessed over network. So maybe a computer, a PC itself, I will be accessing, but
Mm,
robot is simply reading the sensor data and just sending it to some other
mm,
PC, which will process and send back the results. So
huh.
which category does this model belong to? Is it infrastructure as service or software as service?
Um, okay. There it is definitely not your platform service. Okay. Definitely not your platform service. In I don't consider it as a infrastructure service because robot is not doing any this thing, right? Robot
Robot will be
it is just
performing some
collect.
task, but
No, no, no.
decision will be.
Say no, 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 no. Is it performing the task? You said it is just collecting the data and sending the data to the PC. Am I right?
Yeah, yeah, but
Ah,
robot will be performing some task, which that decision of that task will be done by another computer. There will be
ah.
sensors connected to the robot. Robot will read the sensor data and pass it to the PC, and
No, no,
PC
no.
will
The
process it. And
One second, Sagar. There is a difference in you telling two sentences. See, robot will sense the data and send it to the PC is one scenario. That's what you said. Next time you said robot will sense the data, it will compute there, but the decision it won't take, it will send it to the PC. You said that is the second scenario. Those two scenarios are entirely different. Which one you want to do now?
hello, ma'am. Is there any
Ah,
noise in my audio?
no, no, it's proper. It's audible.
Am I audible, ma'am? Clearly?
Yeah, 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 yeah. You're audible, Sagar.
Ma'am, actually, the robot is performing some task like moving,
Ah,
like it's just moving, navigating. For that, it requires to process some of the sensor data which is connected to it. So
yeah.
it is performing some task, but for that it requires all the sensor data to be processed. Just
Ah,
that I don't have the capacity to process that data in the robot, I'll be
okay.
outsourcing it to another
Yes.
computer.
Yeah,
But
yeah, yeah.
robot, yeah, so this will
Yes.
be in which
IAA,
category?
IAAS, IAAS, infrastructure.
Okay,
In,
okay, okay, ma'am.
in,
Because here software is also accessed virtually. So will it also belong to software as a service?
no, 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 no. It is connected to the cloud, right? You're right.
Yeah.
So it is, according to me, it is IAAS.
Okay, okay, ma'am. Thank you, ma'am.
Okay, 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 fine. Next, okay. Anyone else has any doubt? Otherwise, I will move on to Anil. Anil has to unmute now. Anyone else has any doubt? Okay. Anil, hope is in the meeting. Anil, oh, he has mic problem. Why, man? Mic problem? Then who else? Here, actually, I don't have a. Okay. Prajwal is there? Prajwal?
Hello, ma'am.
Yeah, Prajwal is there. Yeah, Prajwal, actually, how do you find this subject? Any difficulty?
Uh, it's okay, ma'am. First, I'm finding it a bit difficult, like to understand all the protocols.
Huh.
Yeah, but it's something similar to the last MCCM, somewhat, I would say.
That's what I will tell you. Till last, maybe, okay, till last two classes, it was similar to your CCN, I can say. Okay, because though it was bit different, I made it like similar to CCN because I enhanced those points only. So it was like, but now onwards, it is entirely different. Okay,
Okay.
so you have to see, don't keep the complete portion till the end. It is going to be difficult, I will tell you. Okay, it is not that easy. It is going to be difficult if you keep till the end, because this situation is new to you also, new for us also. Okay, you all sitting at home and you are studying, only we are sending the videos. Okay, do we won't get whether you have understood or no. Only very few will come up with the doubts. Okay, others, it doesn't mean that others have understood 100%, nor they have not studied only. I know that they have studied, they have gone through the videos, but they have doubts, but they don't come up every time. Okay, I don't comment anything on that, that's not bad. But okay, if the when you have the doubt, again and again, if you read the textbook, here only thing I can tell you is you have to go to the textbook. Okay, again, don't go to make notes and all of textbook. Whatever is there in the textbook itself is very much precised. So that only if you study, and that only if you reproduce, that should be sufficient. uh, Initially, to understand what it is, you need to go through my videos, whatever I have put yesterday. Day before yesterday, what video I had put yesterday, when I saw it was just 13 of them had viewed. Actually, I expected more to view, because I thought that you all are quite regular. Okay, you are, but later I assume that you are busy in your placements, so you did not watch. But please, one after the next one only, you keep on watching. Okay, don't leave anything in the middle, because it is a yeah, PPT wasn't visible at the end, no, Velona. PPT, yeah, I got to know, your CR told me yesterday, but it was only at the very end. Okay, but my audio was there, right? So go through that, and if you want, I will post the PPT once again. Yeah, that is better, I think. I will post the PPT once again. Okay, midway it was stopped. So okay, now you can text me who did Sohan. Yeah, yeah. Okay, now you can text me Sohan and Astrid. Is it okay if I post that PPTs alone in the canvas, or do you want me to record the session once again and post? However you want, I will do it. Just message it, no? PPT will be fine. Fine. I then I will. If anybody wants the PPT is enough. Yeah, yeah, done, done. Okay. Then I will post the PPT, go through that, but don't rely completely on the PPT, please. You have to have the textbook. If I had the soft copy, I would have shared it with you. I don't have the soft copy. So come to the college, collect the textbook. For the first 2 units, we need that. I think if at all internals have to be conducted, then I will be keeping these first 2 units only. Okay, for the test. And assignments, I won't pressurize you, but keep writing, because one fine day when I ask, that time don't disappoint me, then I will be helpless. Okay, I have to give you, if it is there, binary one, completely one. If it is not there, completely zero. Okay, it is going to be like that. So keep writing whatever I say. I don't give any hard assignments. Whatever I have asked you to take down, okay, so those points, write it in a paper. Finally, when I ask, that pic you can take and you can upload. Okay, you can take the pic and upload. So this is about the subject. Okay, please be regular. Otherwise, not only with this subject, with all the subjects you have to be regular, including microwave and antenna. Okay, which at the end it will be very difficult. Even this one, and other subjects also. Okay, DSP, what DIP, all those things. So you need to be regular. Yeah, it is, pressure will be there for everybody. Even we are also highly under pressure. Okay, everybody. But this is the stage. We need to cope up with it, because throughout we are going to get like this only. No time will come. Okay, yes, I am out of like all the pressures. Now I am this thing. Only few moments or very few days we will be in that mode. Rest again. Next again, you will have to proceed. After your engineering, you will have to proceed for something else. So we have to move on with the pressure. You can't take that as a very big drawback or this thing. Okay, now we don't tell that, we don't grumble that, okay, we are pressurized, because we have been doing that only throughout, either this or that, online class, offline class. So we don't complain, or it is not a burden for us. So similarly, that this thing even you need to develop. Okay, with whom and all you keep on complaining about. Today us, okay, next your parents, next your boss. Who, how long, who will listen? You think yourself, and why they will listen. Okay, after all, how many these things, okay, whoever has said about their pressure, how many how much importance you have given, similarly it is. Okay, so try to cope up with your subject. Any other thing? Otherwise I'll wind up here. Anybody? You can text me. People find that is very comfortable than coming online. Anything? No, right? Okay, those are placed during the last week. For them, congratulations. Okay, others, now actually this is the season. Please try hard. Okay, again in the 8th semester we may not get so many, and now since this is the thing, it is really since it is online also, that is one advantage. For some it is, I call it as an advantage only. So okay, try hard with whatever in the next forthcoming your placement activities. Okay, if nothing is there, if no doubt, then I think I'll wind up. Thank you.